Hello and happy Thursday. So thanks for checking in and staying on top of things. I hope you're doing well. Yesterday you were able to, yesterday the video you watched was kind of a really quick overview of quadratic, some things that you knew and some things you didn't know. So we're going to take some notes today and really nail down some of those topics that were mentioned. So first, let's remind ourselves that a quadratic function is any polynomial with a highest degree of 2, so an exponent of 2. So some examples here might be something like 3x squared plus 5, or x squared minus 2x plus 1. So since those all have that highest exponent of 2, we would have a quadratic function. Now, y equals x squared. So y equals x squared is a really special quadratic function. This is what's called the parent function for all quadratics. And what that means is that all other quadratics are based off of it. All other quadratics are based off it. So this is like the base model here. Every other quadratic is just some version of this. So y equals x squared, that is our parent function. And so we get that by simply substituting each value in for x and squaring it. So for instance, negative 4 squared is negative 4 times negative 4, which is a positive 16. Negative 3 squared, or negative 3 times negative 3, is positive 9. Negative 2 squared is negative 2 times negative 2, which is 4. Negative 1 times negative 1 is positive 1. 0 squared is just 0 times 0, which is 0. And then if we square these positive numbers, 1 squared is 1 times 1, or 1. 2 squared is 4. 3 squared is 9. And 4 squared is 16. So you might notice with this table that we've got some numbers that start to repeat themselves here. That's important. Keep that in mind. If I convert this table into a graph, it's going to look something like this. I'm just going to plot each one of those points. 3, 9, and negative 3, 9. Now the negative 416 and the 416 are off my graph, but since we know we're there, we're going to draw our curve in here and put arrows at the end because we know that it extends upwards. Now, if you remember what this kind of graph is called, great. If you don't quite remember what it's called, this is a parabola. Every quadratic function, the graph is called a parabola. Like linear functions are called lines, quadratic functions are called parabolas. So we've talked about some key features here, some important parts to this graph, but I want to give them names, especially since you watched your video yesterday, and talk about what they mean. So some key features here. Every parabola has a vertex, which is the turning point of the graph. So it's the point on the graph where it turns around, right? So on our graph up here, where our parabola turns around is this coordinate point, 0, 0. So I'm just going to make a note to myself that that is the vertex, 0, 0. Now, we talked a little bit about some other descriptions for the vertex. So for instance, the vertex in this case is a minimum. It's at the bottom of the graph. The parabola is opening upward. So if the parabola opens upward, and I'm just going to draw a picture for myself there, right? If it's opening upwards, then our vertex is at the very bottom of that graph. On the other hand, the vertex can be a maximum if the parabola opens downward. So opening the opposite direction, the vertex would then be at the very tippy top of that graph. So we've talked about the maximum and minimum, but we haven't really given it a name up until this point, and it is called the vertex, the turning point of the parabola. Now, besides a vertex, every single parabola also has something called an axis of symmetry. And so that axis of symmetry, if you remember what symmetry means, right, it's kind of like mirror image. Axis is a kind of line. So the axis of symmetry is actually a vertical line across which the parabola is symmetric. So it's like if we put a mirror in the parabola, we would see the mirror image on either side of it. So it's a vertical line across which the parabola is symmetric. So if we look back up here at our parent graph, y equals x squared, I should notice that if I were to hold a mirror right here in the middle of the graph, we would see the same reflection on one side as on the other. So that makes this line the axis of symmetry. Now, if you'll notice, that axis of symmetry goes right through the vertex, and that's actually always going to be the case. So the axis of symmetry always goes through the vertex. So I'm going to make a note of that because that's going to be really helpful in the future. The axis of symmetry always goes through the vertex. Now, some of these other features you've heard before, we've talked about them, so I just want to make sure that we remember what they are. The y-intercept of a parabola is the point where that parabola crosses the y-axis. Another way to think about that is that this is where x is equal to 0. So we could find it graphically, or we could find it by setting x equal to 0. On the other hand, the x-intercept of a parabola is the point where it crosses the x-axis, which is also where y is equal to 0. So y-intercept and x-intercept, we're pretty familiar with those concepts. Some other concepts that we've talked about before but haven't discussed in a little while is domain and range. So let's talk about domain here for a minute of parabolas. Now remember that domain refers to the x values that are covered by the graph. And we put those arrows on the ends of the graph intentionally because it goes on forever and ever and ever. And if you notice, it actually goes up and to the right and up and to the left. So the fact that it goes to the left and to the right forever, it's actually, any parabola is always going to do that. So our domain is always going to be from negative infinity to positive infinity. It goes left and right forever and ever and ever. The range, on the other hand, depends on, or remember, the range refers to the y values that come out of the graph. And in this case, a parabola is always going to have some limitation, right? It's not going to just go from negative infinity to positive infinity. It actually depends on whether the parabola opens up or down. So it's either going to go up forever and ever and ever or down forever and ever and ever, but it's not going to go both directions. So we're going to do some examples together just to remind us of some of these key features we already know, and then get to know vertex and axis of symmetry a little bit. So if I scroll down a bit, example 1. So example 1, I've got this lovely parabola here, and I'm going to identify some features. So first of all, my vertex. Well, my turning point of my graph is right here at 3, 6. So that must be my vertex. 3, 6 is that coordinate point. So whether the vertex is a maximum or minimum, since it's at the very top of this parabola, right, it's opening downwards, that makes this a maximum. It is the highest point. The axis of symmetry, remember that's that vertical line that shows us where the graph is symmetric. So I can draw it right down the middle of the parabola. It goes through my vertex. That's what I want. Now, since this is a vertical line, every single point on this vertical line has the same x value of 3. So we're going to write this as x equals 3 because it's a line, so we need to use an equation of a line, and we're going to use that x value. The y-intercept, where it crosses the y-axis, appears to be right over here at 0, -3. Remember, these are coordinate points. We have to write them as coordinate points. The x-intercept, where it crosses the x-axis, we might have to do a little estimation here. It looks like it happens twice. This looks like it's at about 0.50 and 5.50. So about halfway between 0 and 1, and halfway between 5 and 6. Now, last but not least, the domain and range. So ideally, if I had remembered to put them here, there would be arrows at the end of all of these. So this parabola goes down forever, but it also goes to the left and to the right forever. So our domain in the x direction is from -infinity to +infinity. And then our range, so it has this highest point right up here at 6, and it's going to go down forever, but it's never going to go above 6. So we're going to say that our range is all y values less than or equal to 6. That's the highest y value, and then everything below it is covered. So there is an example down here titled "You Try." So I am going to have you try that and then check back in here, and we'll compare our answers and see how you did. So let's check out how you did here with this example. So your vertex should be right here at -1, 1. Since this graph opens upwards, this is a minimum. The vertex is at the very bottom of the graph. The axis of symmetry goes right down the middle, and make sure when you write it that you say x equals -1. It should have x equals there. I'm going to be nitpicky. Our y-intercept is 0, 2. Then our x-intercepts, we might have had a question mark about that because this does not cross the x-axis, and that's okay. We're going to talk more in a few weeks about what that actually means, that there is no x-intercept, but right now we're just going to say none. That's okay. Our domain is every x value from -infinity to +infinity. It goes to the left and to the right forever. And then our range, our lowest point was +1, and then it goes up and up and up forever. So we should say y is greater than or equal to 1. So hopefully that went well. I'm going to ask you to do a few more practice problems. So if you scroll down here, these practice questions below, oops, there they are. So it looks like there's a lot here, but remember, we're kind of just doing the same thing over and over again because I just want us to be familiar with these features. So go ahead and try these out on your own. Some follow-up questions are going to appear just to see how you're doing. But otherwise, check back in a few hours on OneNote for the answer key, and you can compare there. And if you need to, we can talk about it in our Zoom meeting. So stay well, do something fun today in addition to this, and take care of yourself. And I will talk to you soon.